On everybody? If you're looking to learn a little bit about the distributive property, you've come to the right place. And I have to say that the distributive property makes, alright, it's on my list, it is in the top 5 things you need to know for Algebra 1. It is so important. Basically, once you learn the distributive property, there is no going back. We distribute a ton, so much distributing. So I hope you're ready to give me your full attention for this because it is super important. Also on the list, we've already talked about it, it's called combining like terms. Again, always, every day you will be combining like terms, but right now we're just talking about the distributive property. So let's just talk about what it is conceptually. The distributive property just says what you do with one piece of the whole, you do with the entire whole. So I'm going to talk about pancake math. If you want to make pancakes, chances are you're going to follow a recipe. And this one seems like it's a pretty decent recipe. We got 22,000 people that like it on Pinterest, 16,000 people that like it on Facebook, etc., right? Pancakes. So when you want to make more pancakes, you just don't throw in more milk haphazardly, you just don't put in more flour, you go, handful here, handful there. That's not what you do. If you want to make twice as many pancakes, what you do is for each one of these, each one of the ingredients, you would do times 2. Do you see what I'm saying here? The pancake is the whole, but it's made up of all of these different ingredients. So if you want to double the amount of pancakes, you have to double each of the individual parts which make up the pancakes. Now in math, we can see individual pieces of a whole with our good old friend, the parentheses. So we're going to take a look at some mental math skills that use the distributive property. So if you've ever encountered someone that you think is really good at multiplying in their head, chances are they're using the distributive property. I'll show you how. Well, let's look at our first example. 3 times 15. Well, you could just say, bam, it's 45. Or you could look at the 15 as 2 separate parts. Often, it's helpful to break a number into its tens digit and its ones digit. So I can break the 15 into 10 plus 5. Now, why would you want to do that? Well, the distributive property. Because if you multiply 3 times 15, you have to multiply it by each of the parts, the 3 times the 10 and the 3 times the 5. And those are all pretty straightforward routine multiplication tables that everyone's familiar with. 3 times 10 would give us 30, and 3 times 5 would give us 15. What does 30 plus 15 give us? 45, just like I said at the very beginning. Let's try it again with another one. 8 times 12. Again, you could look at that and go, bam, 96. Or you could break it up into 2 smaller chunks. 10 plus 2. That's one way to write 12. Times 8. Let's try it out. 8 times 10. Well, that gives us 80. 8 times 2. That'll give us 16. And 80 plus 16 is 96. So like I was saying, if you find someone that's really good at multiplying, chances are they don't have all these things memorized. They're breaking it down into 2 or 3 pieces and then recombining them back together. You don't have to just change the number inside the parentheses. You can switch it up, like over here. Let's see, 37, well, the 37 would be 30 plus 7, and let's put the 3 over here. 3 times 7 would be 21. 3 times 30 would be 90. 90 plus 21 would give us 111. Now here's something that I haven't shown you yet. In all of these examples so far, I've used plus. You can still use minus with the distributive property. Instead of using my 28 and saying 20 plus 8, I'm going to back it up. I'm going to say 30 minus 2. And now we're going to multiply each piece of the whole by 5. 5 times 30 would be 150. And 5 times a negative 2 would be a negative 10. That's a real nice subtraction for us, 140 in the end. So the distributive property is great because it helps us with mental math. But not only that, it helps us combine like terms in the future. We're going to try some examples with variables, and I want to show you that it works exactly the same way. We just need to pay attention to our x's. So here, I can see in the parentheses, we have two parts to our number. We have the 3x part and the 7 part. Well, the 2 out in front means double it. 2 times 3x would mean that I have 6 x's. 2 times 7, well, that would give us 14, and that's our final answer. By doubling the whole thing, we need to make sure that we double each individual part, each ingredient. Here we go for the second one. 9 times 8, that will give us 72. 9 times negative 2x, negative 18x. That positive times that negative still gave us a negative, and that's our final answer. Now you got to be super careful when your coefficient out in front, the number out in front is a negative, because that means that you must distribute the minus sign as well. So here, this minus 3 needs to get multiplied by that 5x. Minus 3 times 5 would be minus 15. And the x is there, so it's 15x. The negative 3 times a negative 2. Negative times negative makes positive. So again, watch out for those minus signs in front when you're distributing. They come along for the ride. Here, last problem. Minus 7 times positive 7 will be minus 49. And the minus 7 times a positive 4x, negative 28x. So that's the distributive property in a nutshell. What it means is that if we want to multiply something to a whole, and usually that whole is in parentheses, it means that we need to multiply to each individual part of that whole. Our rules with negative signs carry over. Our order of operations still carry over, but I really hope that this helps you out. Ask me any questions in class if you still want some extra practice problems or you want to just sort something out. So, see you tomorrow.